So on Monday's work, you saw what the graph of sine of x looks like. And so we're starting today by taking a look just, okay, how do sine and cosine compare? So like here we can see those two different graphs. So notice cosine there in blue, it started at the top, it went down, then went back to the top. Cosine, the one in red there, it starts in the middle and then goes up and then goes down and then goes back to the middle. But notice it really is the same shape of the graph, yeah. As you said, it's like sine is the exact same graph as cosine except shifted 90 degrees over to the right. If I took my cosine graph and shifted it over that way, you would get the exact same graph. It is literally the same thing. All the little details and all that stuff would be the same if we did that. And so we started out this section just focusing on cosine and getting all the little details down with cosine. And then we're throwing sine here basically kind of at the last minute. But that's because you already know how to do it. If you see this difference. The big thing that you need to know about sine going forward is that sine starts in the middle. So in other words, it starts on the midline, and it is increasing from there. If you remembered that about sine, well, you know how to graph it then because you know how to graph cosine. Above your first graphing grid that you still have spare there, please write this equation, and then we're going to go ahead and make the graph of this equation here. And I want to start this graph the same way that I start any of my other graphs. I want to start by drawing in a dotted line first for the midline. So where is my midline in this particular equation? It's always what's added or subtracted onto the end. So yes, it is the -1. Excellent. And so our midline here is going to be y equals -1. So the first thing I'm going to do on my paper is I'm going to draw in a dotted line like that. Now some of you lament the fact that you can't draw that in on the computer. But you can draw it in on your paper. If you find that graphing on a computer is tricky for you, graph it on paper first, and then just copy the graph into the computer. The next thing I draw in my graph here is my top and my bottom guides. And so those are all determined by the amplitude. My amplitude here, remember that's whatever is multiplied out front. So that's the 2. So my amplitude here is 2, meaning that I'm going to put a dotted line 2 above my midline, and then I'm going to put a dotted line 2 below the midline. Now you'll notice that so far in making this graph, one thing I have not even talked about or even had to consider was the fact that this one was sine instead of cosine. That's because up until this point it hasn't mattered. Really all that part is going to tell us is whether we start at the top or start at the bottom or start in the middle. It's all about the starting point. So since this one is sine, where does my first point go? On the top, the middle, or the bottom? Sine starts in the middle. And so I'm going to put my very first point on my midline. Make sure to plot that point there. And if you want to put a little box around it or an arrow pointing at it, something like that to help yourself remember that was where your first point went, that's a great thing to be able to do. Because this is now the graph of sine. So it starts in the middle. Of course, whenever we're at the middle, we have a couple options. We need to know, are we going to be going up or are we going to be going down from the middle? So sine starts in the middle and then it is heading upward. Yep. And so I'm going to go middle, top. Now there's no questions left about how we proceed from here because it really is now the same pattern as we did with cosine. So I jump into my pattern, I'm at middle, top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom. You know the drill, right? We just plot each of those points, and then once you plot them, then you can go ahead and draw your curve that goes through them. All right, and so now we're going back to a little bit of practice on finding period, amplitude, and midline. But Y'all are pretty good at these, except for one little detail. There is one scenario where sometimes we still get a few questions out there. And that is when finding the period when we're in radians. And notice, that's what we're practicing here, is what happens when all of a sudden we're in radians. Because we got really good at doing it when we were in degrees. Remember, when we were in degrees, we saw that we just do 360 divided by whatever my b value was. B specifically being whatever number is multiplied by x or theta on the inside there. Well, in this case, so 360 wouldn't make sense, because 360 is the number of degrees in a circle. And of course, we aren't working with degrees, we're working with radians. So how many radians are in a complete circle? In other words, 360 degrees equals how many radians? It is 2 pi. And so it's the same idea, just now since we're in radians, we have to do 2 pi divided by whatever that number is multiplied out front. And so that'll give us our period. For amplitude, does the fact that we're in radians affect the amplitude? No. Does the fact that we're in radians affect where the midline goes? No. The radians is only affecting how far you're going over every time. And so this is what your first one would look like. I start by doing 2 pi divided by 10. Basically think of that as 2 pi over 10, and that gives me pi over 5. Yes, go ahead and leave it in exact form. You don't need to put them into the decimals there. My amplitude is 1 because there's nothing multiplied out front of the cosine, and my midline is at y equals 0 because there's nothing added on the end, so it's unchanged. Repeat the process for the other two now. Next up, we're just going to take a look at some graphs. Now, you can write these down or not as you wish. I'm going to go through them on the slightly quicker side because we're throwing in a little bit of a new wrinkle here, and we just kind of want to introduce what this one little wrinkle does to it, and then we're going to move on through it. You'll notice here that we're graphing x minus pi over 2. As you might expect based on that little hint there, we're going to graph this one in radians. Now you notice, none of my scales are labeled here. Well, normally, I'd be putting my far one, my far right, out at 360. Well, if I'm in radians, I don't want to label it 360. What do I want this label to be out here? 2 pi, exactly. It's got to be the full circle in radians instead. So I'm going to label that 2 pi. Now, if that is 2 pi there, what are the rest of these labels going to be in between? Well, an easy one when setting up this scale would be like the halfway point right here. The half of 2 pi, of course, would be pi. Half of that would be pi over 2, right? But that just leaves us with this last one. What is this label going to be then? Well, notice this is half of pi. This is 1 pi. So this would be like 1.5 pi, or 3/2 pi. It is 3 pi over 2. We could also see that by thinking of, well, normally it's 270 degrees, and 270 in radians is 3 pi over 2. It's another way to do it. And so now, if I set it up like this, and then I go to make my graph, what does the fact that I have this in radians really change? Not much. I still would approach it the same way, where I'd draw in my midline up at 1, I'd be going 3 above it, and I'd be going 3 below it. And then sine would start where? Top, middle, or bottom? Where does sine always start? Top, middle, or bottom? Middle. So my first point's going to go on the midline, but in this case, that's going to be over by pi over 2. Now remember, minus goes to the right. So I put my first point right there. And if you know to put your first point there, then you know how the rest of the graph is going to go, because it goes middle, then sine goes to the top, middle, bottom, follow the same pattern as you go to the left. Now, one little thing to look out for when putting this pattern in, going from right to left, is remember that you are following the pattern. It is not going to all of a sudden bounce up. And sometimes I see people do that, where they just want to say, okay, well, I start in the middle, and so I always go up after that. Not when you're going to the left. It would follow the pattern, it would go down to the bottom there. And so this is the actual graph of this particular one. The only real difference between this and other graphs that we've done is the fact that it was all in terms of radians instead of degrees. And so now we're going to take a look at this one, which is going to feel very similar. In this case, notice we're being told that we're going to be graphing this one in degrees. And I want to label my x-axis the way I always do here. So what does that mean I should make this last label? 360. Yep. And we get there by going at 90-degree increments. So we normally go 90, 180, and then 270, right? And then we can graph sine of 2 theta here. Now the 2, does it make my graph wider or does it make my graph narrower? Narrower. Remember, whenever we're doing something in the x direction, it's kind of counterintuitive. 2 actually squishes it in. And so if I rough out what my graph is going to look like here, instead of putting a point every, this one's sine, instead of putting a point every 90 degrees, I'm putting a point every 45 degrees. And so there I've completed one full cycle between 0 and 180, and then I would complete the second cycle, which of course is what the 2 really means, is that it completes 2 full cycles, and I'd draw the graph that goes through it. Okay, fine. That's the sort that we've been doing a lot of. But there's one thing that oftentimes will happen when we graph sine and cosine is we'll get dealing with some wonky numbers or something like that, and we'll decide we want to make that same graph, but we just want to show what a single cycle looks like. Well, if I wanted to graph just one full cycle between start and end of this particular graphing grid, what would I need to label this as in that case? And so in order to be able to do that, I'm figuring out what the period is. So I'm doing 360, because this one's degrees, divided by the 2 that is on the inside with the theta here. And so I'm going to do 360 divided by 2, which tells me that is 180, which tells me that this label down here needs to be 180 degrees. And remember, that meant that we were putting a point every 45 degrees. So we go 45, 90, 135. Now, since I changed my labels that way, when I go to graph my sine starts in the middle, and I'm putting a point every 45 degrees, but notice now the spread of 45 degrees has me out further. And so in doing this, I've made the same graph. I have the same numbers in there, except I now chose a scale to allow it to just show one full cycle instead of just going with whatever we call the normal scale. Because actually the normal scale we use, there's nothing magical about it. It's really just a nice starting place for learning how to graph these. But as you go forward, more and more, we're going to start messing around with that scale. And so I want to practice that same idea with this one. So now we're going to take a look at the graph of cosine of 1/2 x. Now, notice here, x, we're told, is measured in radians. Now, if x is going to be measured in radians, and I'm going to use my typical labels that I use, what do I typically go out to at the very end if I'm going to be in radians? Yeah, that one's going to be 2 pi. And so I call that 2 pi. Now, do you remember what the other labels end up being then if that's where 2 pi is? We talked about it just once so far. Well, our first one is pi over 2, and then pi. Those we can usually get kind of intuitively. You can actually figure out this third one intuitively too, but it tends to be the trickiest one. This third one is like 1/2, or in other words, 3/2 of pi. So we do 3 pi over 2. Now, having done that, I'm going to go ahead and make a sketch of my cosine graph. Now, the 1/2 that's inside here, that affects my period. Does that make my graph wider or narrower? Wider, absolutely. And so this one is going to be twice as wide, meaning that instead of putting a point every pi over 2, I'm going to put a point every pi. And so in this particular case, I only fit 3 points. But that's all we would need to fit because that's as much graph as we get. I'm only completing half of a cycle in this particular case. But just like we did with the last one, I can actually mess with the scale that I'm going to label on my axes so that we can fit on one full cycle. So if I wanted to fit one full cycle in this particular graphing grid, what would I label that last x coordinate? So again, we would figure out the period basically, is all we would have to do there. And because we're in radians, we do 2 pi divided by whatever that b value is. Well, 2 pi divided by a half, that's the same as 2 pi divided by, 2 pi times 2. And so that is going to give me 4 pi. And so we would label that as 4 pi. Actually, in this case, making the scale is almost easier once you know that, right? Because half of that is 2 pi, half of that is just 1 pi, and of course, notice we're counting up by pi's, so this would just have to be 3 pi. Having done that, if you go to make your graph, cosine starts at the top, remember? And then I'm putting a point every pi, just like I did in the last one, except in the last one, I was done when I hit 2 pi. But in this case, you'll notice by choosing a different scale, we're able to actually fit a full cycle on there. And it's actually the numbers on the axis that we got to pay attention to be able to tell how our period was changed and how this whole thing was stretched or condensed.